Now this is the classwork that we'll be working on today, and after I get through showing you first how to determine whether it's direct variation, we're then going to find the constant of variation, and then we're going to go ahead and derive the equation from this table so that you'll know how to do that. So let's start with the first part. So right here it says determine whether each linear function is direct variation. So you should box that. That's what you're looking for. If so if it is, determine the constant of variation. Now when you say, okay, what is direct variation? Well, remember that is going to mean that it is proportional. And the constant of variation, that's the slope that is constant when we have a proportional relationship. So let's go ahead and take a look at it. In order to do this, what we want to do is we want to go ahead and we want to set up a ratio of y to x and then confirm that it's constant. So when we look at a ratio of y to x, we're going to have y over x. Just like when we did slope, rise over run. So let's take a look. Our y values are at the bottom, they're the mass, and our x values are at the top, they're the volume. So if I want to get my first point, my first ordered pair, when we're talking about an ordered pair, we're talking about something that looks like this. If we had it, we'd write our x first, 2, and our y second, 10. Now this ordered pair has been put into a table for you. So we're just going to take it out of the table, 10 and 2. So we'll have the y on top, x value on bottom. That gives me 5. So right now, just looking at it, that's what these two ordered pairs, when we go ahead and create a ratio out of them, it equals 5. Now, if this is direct variation, if it is proportional, we should be able to do that for every one of these sets of points on our graph, and we should be able to get that same value of 5. So let's check the next one. It's 20 over 4. So we'll write that 20 over 4, and 4 going to 25 times. So far we're good. But we'll keep on going because we want to make sure that all of them check out. So now we have 30 over 6. 30 over 6. If we punch that into our calculator, I don't know, I'll just show you if you wanted to. I think the best way to put it into our calculator is to go ahead and put in our fraction bar, and then we can put in 30 over 6, and it equals 5. So we'll write another 5, box it. Now we just got one left to check, and that is going to be our 40 over 8. And once again, if we take our calculator and we put that in, 40 over 8, it gives us 5. Now, what I want you to notice is, notice how these ordered pairs, when we set them up and we create a ratio, they are all equal to 5. Do you see how that repeats? That's what we call our constant of variation. And when we have that, we know that it is a direct variation problem. So it says to determine whether it was direct variation, so we'll say yes, because it is direct variation. So that's to the first part of our question. The next thing we'll do is go ahead and write our constant of variation, which is 5. Now in this case, whenever we have a graph that's proportional and we find that constant of variation, that is going to be our slope. And I'll give you an example. I'll show you how we can determine that. Let me erase this. I want you to watch this. If my change in x from 2 to 4 is 2. And if you're going, well, how did you know that you have a change of 2? Well, I just take this x value and then subtract this one from it. In other words, I go 4 minus 2. It gives me 2. So you see that right there. So now I can check my next one. 6 minus 4. 6 minus 4 is 2. And then 8 minus 6. So 8 minus 6 is 2. Then I can go, okay, well, if I look at my change in y values, I have 20 minus 10. That's this 20 minus 10. That's going to give me 10. 30 minus 20 will also give me 10. 40 minus 30 will give me 10. So I could look at it this way and say, well, here's my slope. My slope is actually 10 over 2. And if I go ahead and divide that into each other, it's going to give me 5. So in this case, when we have a direct variation problem, whenever we set our points up as a proportion, notice that it gave us which was our slope for our equation. So now that we know that, we know a couple of things. We know that our graph, if we were to draw it, that it's going to cross through origin, right? So we know that whenever we have a direct variation problem, it's always going to be in the equation of y equals mx. And at this point, we know what our m is. Remember in our Cornell notes, we said, what does m represent? And that is our constant of variation when we have the equation of y equals mx. So all we need to do is plug in that value for it. So our equation here is y is equal to 5x. So yes, it is direct variation. Our constant of variation is 5. And now you know how to write your equation. Y is equal to 5x. So let's take a look at another one. I'm going to skip around. Let's go on and do number 3, because at this point you should be able to do number 2 on your own. Number 3, just looking at the numbers, it looks like it may not be direct variation. So we're going to check a few things on it. So if I go from 8 to 9, it's 1, 9 to 10, 1, 10 to 11, 1. 68 to 71, we have a change of 3. 71 to 74, a change of 3. 77 minus 74 is also a change of 3. So here's my slope. So my slope at this point is going to be 3 over 1, or it's going to be 3. Now, it didn't ask us to check for this, but I'm just showing you, reminding you, we did this the other day. This is how you find the slope of a line. This is a line, and it does have a slope. What I want to know now is this direct variation? Is it proportional? And remember, if we want to check and see if it's proportional, we need to set up a ratio of y over x and check each one of these points, and they should have the same value. So let's do the first one. Let's say y over x, and we'll do 68 over 8. And if I put that into my calculator, so I'm going to go ahead and do 68 over 8, enter. It gave me 17 over 2. Okay, so it gave me a fraction. So the next points I check are going to be this one right here, 71 over 9. So let's do 71 over 9. Now remember, if this is direct variation, when I check this right here, this ratio, 71 over 9, it should give me this same value, 17 over 2. If it does not, then that tells me it is not proportional, and it is not a direct variation problem. So let's go and put that in, 71 over 9. Hit enter. Look, it didn't change it. It stayed exactly the same. It can't be further simplified. So with that being said, my answer being 71 over 9, I can just simply stop right there and go, well, looking at these two, they are not equal. And remember, if they are not equal, it is not proportional. And if it's not proportional, it is not direct variation. So with this one, there's no need to go any further. I'm not going to show you how to write the equation for this particular linear relationship, because we're going to do that on Wednesday. So if you run into one like this, don't worry about trying to write this particular equation, because it's going to be different. So let's just go and write our answer. We can say no, because it is not a direct variation problem. And then what we can do is it tells us to explain. It says if not, explain why not. So let's explain it. Well, the ratio of time, because notice it has time to temperature, of time to temperature is not constant. So how do we know it's not constant? Because when we set up our points as a ratio of y over x, our values were not equal to one another. Therefore, it is not constant. The ratio of time to temperature is not constant. And that's what we have. If we take a look at it, what do we have right here? We have On top, this y represents our temperature. I'm just going to put temp. And on bottom, this represents our time. So we're just setting up a ratio of time to temperature. And it was not constant. Now, is it linear? Well, yeah, it's linear. Notice, right, we had a 1, 1, 1, 3, 3, 3. We even got a slope from that. So it is a linear equation. And it can be graphed as a straight line, but it is not proportional. So this means this particular one does not cross through origin. If we were to draw a graph, it's going to look something like this, because it won't go through origin. It'll have a y-intercept of some kind. So now that we've done those two, I'm going to let you do this next one on your own, or finish it up if you didn't get to finish it in class. And let's go ahead and move this up here and do some of these problems. This one says for exercises 5 through 8, y varies directly with x. So that means that it is a direct variation problem. Write an equation that's similar to what we did up at the top. I showed you how to write an equation for the direct variation. Then determine each value. Okay, so we need to read these really careful when we're doing this. First it says if y is equal to 27 when x is equal to 8, determine y when x is 11. So with that being said, we don't have a table, but they're giving us the information that was in the table. If we had a table, our x value would say 8 and our y value would have been 27. But we can set up a ratio with these two items. So let's go ahead and do that. Remember, our y is going to go on top, our x is going to go on bottom. And it says if y is 27 when x is 8, okay, well, so my y is 27, my x is 8. And let's go ahead and see, can we further simplify that? Now if you want, you can just use your calculator to do that. Oh, let me escape there. So if we go here, and we're going to do 27 over 8, enter. Nope, it didn't change, it stayed exactly the same. So with that being said, I'm going to go ahead and leave that just like it is. So it wants us to go ahead and write an equation. And remember that in a proportional relationship, or a direct variation problem, we can use this as our slope because it is our constant of variation. Therefore, this is equal to m. Knowing that, I need to write the equation in the form of y equals mx. Well, we know what our m is. It's 27 over 8. So if I were to rewrite that, it would say y is equal to 27 over 8. That should be x. So this is our equation now. We have y equals 27 over 8x. Now the next part tells us to then determine each value. The value it wants us to determine is that determine y when x is equal to 11. So if we want to do that, we're simply going to plug in our x value of 11 in place of this x. And I had told you last week that we would be starting to plug in numbers. I even worked one problem where we did plug one in to give you an idea of what we're heading towards. So let's go ahead and do that. So my equation is y equals 27 over 8 times x. For my x, I'm going to plug in the number 11, because that's what it's telling me my x value is. So I have 27 over 8 times 11 is equal to y. So y is equal to, I just need to multiply these two things. So let's go ahead and put that in the calculator and see what happens. Alright, if I put that in. So there's my fraction bar. I'm going to do 27 over 8. And now I'm going to put a parenthesis. I'm going to multiply that to my 11. Now it looks just like my equation, right? 27 over 8 times 11. 27 over 8 times 11. I'm going to hit enter. And it gave me a large fraction. So let's convert that real quick, because I think it'd just be nicer to have a decimal number. Not that I'd count it wrong if it was like this. But let's try to make a clean number. So we got 297 over 8. Remember, if you put a decimal after the 8, how I put that decimal after the 8, it's going to give me a decimal answer. So it equals 37.125. So y is equal to 37.125. And that's the second part of our answer. So now we have our equation, and then we have our answer for y when x is 11. So whenever we plug in 11 for x, when x is 11, this is going to be our value for y. Now I'm going to show you on your calculator. If we wanted to try this out, we could have found this by plugging this in and graphing. On your calculator, this will be the first time you use this function. You can go down to graph, hit enter. When you do that, we can go ahead and put in an equation. Graph. I'm going to go down to graph and hit function. Notice it has f of 1 and it says f1 of x. So that's just a function that represents my y. I can plug this in. So I'm going to go ahead and put in 27 over 8. And then I'm going to multiply it. Let's see, I'm going to put my x in, x, hit enter, and it's going to graph that function. Then if I hit control and the letter T, I can pull up a table and I can check my answer. It says when x was 11, my y should be 37.125. So let's see if that's correct. I'm going to go down to 11, and there it is. It says when x is 11, my y is 37.125. So now I know for sure that I have created the correct equation and I have created the correct answer by plugging in that 11. So this way, graphing it and looking at your table is just a shortcut to get to the answer, and we're going to work more on that as we go through these types of questions through the week. But for now, you know how to do it manually. That's very important. And then we can practice this a little bit later in class of doing it electronically. So how about we do one more of these? And let's see, number 8 actually has you solve a little bit differently because you're going to be solving for the value of x. So let's look at number 8, because number 8 is a little bit different, and I think some of y'all might get confused on this one. So let's take a look at what we got. If y is equal to 20 when x is equal to 8, okay, that's given us our proportion. So let's go in and plug in our numbers. Our y is 20, our x is 8. What is the value of x when y equals negative 2? Now, we have been looking for the value of y when x equals some number, but in this one, look, they've changed it on us. Now we're looking for x when y is equal to a value. So let's go ahead and turn this into a good clean number. And let me go ahead and put this in my calculator. I'm going to go back to calculate, and we're going to put 20 over 8. So let's do 20 over 8. Let the calculator simplify it for you. So it's 5 over 2. So we can say, okay, this is 5 over 2, and that's going to be equal to our m. So my equation is going to be y equals 5 over 2 x, because the 5 over 2 is our m. With that being said, what we're going to do now is plug in our y value. So it says y is equal to negative 2. So for y, I'm going to plug in negative 2 is equal to 5 over 2x. Now this, at this point, this may look familiar to you. You may recognize, hey, this is just a one-step equation. And so it is a one-step equation. So we're going to use inverse operations in order to undo x times 5 over 2. And when we do that, we'll be able to solve what our x value is. So 5 over 2 times x. What is the inverse operation, which means the opposite operation of that? And the opposite of multiplying is dividing. So I'm actually going to divide by 5 over 2. When I do that, 5 over 2 will go into 5 over 2 one time. So those cancel out. I also have to do the same thing to the other side of the equation, because remember, whenever we're working with equations, we always have to balance both sides. So now I have x is equal to negative 2 over 5 over 2. So let me rewrite that. X is equal to negative 2 over 5 over 2. So this may look complicated because you have a whole number being divided by a fraction, but don't worry, because our calculator will do all the work. So let's go over here, and we're going to go ahead and put that in. So I'm going to put in my fraction bar, put in my negative 2, and then once I go down to the denominator, I want you to go ahead, by the way, let me dim this down a little bit. I want you to go ahead and put in another fraction bar, and then put in your 5 over 2, just like that. Now once you do this, hit enter, and look what it gave me. Negative 4 over 5. So I'm going to go ahead and write my x over here and say x is equal to negative 4 over 5 when that is the case. So now we have the two things that we needed. We have our equation, which is y equals 5 over 2x, and then we have our answer for what the value of x when y is negative 2 and that is x is equal to negative 4 over 5.